Welcome back to my channel. In today's video lesson, we are going to talk about quantum numbers and then the calculations involved in quantum numbers. So with talk of quantum numbers, we have four main types of quantum numbers. This must be noted. We have four main types of quantum numbers. And what are they? The first one is the principal quantum number, right? The principal quantum number. The principal quantum number. I'm using Kn as quantum number. All right. And then we have the azimuthal quantum number, or you can call it the subsidiary quantum number, or in other way, you can also call it the angular momentum, right? So we have the azimuthal quantum number, the azimuthal quantum number. All right, and we have the spin quantum number, the spin quantum number, and you also have the magnetic quantum number. You have the magnetic quantum number, magnetic quantum number. All right, so we are going to take them one after the other. Now, principal quantum number is denoted by the letter small n. Small n, not capital N. Capital N can mean nitrogen. Capital N can mean nitrogen, right? It is noted by the letter small n. And then azimuthal quantum number or subsidiary quantum number, or you can call it the angular momentum. It is also denoted by the letter small l. Small l. It's not capital L. Capital L can be mean liters, right? Now, spin quantum number is denoted by the letter, spin quantum number is 1/2, negative 1/2, or plus 1/2. This must be noted. Then we have the magnetic quantum number. It is denoted by the letter ML. Is that right? So we are going to take them one after the other, and also the calculations involved in quantum numbers. All right, guys. So we are going to talk about the principal quantum number. I told you that we are going to take them one after the other, then we will see what it entails. All right, now principal quantum number. What does it describe? One, it describes the mean energy level of an atom. It describes the mean energy level of an atom. All right, it also describes the shape, the size of an orbital. All right, it describes the size of an orbital. It describes the size of an orbital. Now, what is this orbital here? Now, when we talk of orbitals, it is the region in space in which electrons are likely to be found. Is that right? It is the region in space in which electrons are likely to be found. Now, when you take the atom like this, you see, the center here is the nucleus, right? We have the proton, the electron, and also the neutron, right? The proton is the positive charge, the electron is the negative charge, but the neutral is what? The neutron is neutral. Then the protons and then the neutrons are found in the nucleus of an atom, right? But the electrons are found on the shell, right? So the electrons are found in the orbitals, and the orbitals is the region in space in which electrons are likely to be found. Is that right? All right, then the principal quantum number, it also describes shells, right? It describes shells. And what are the shells here? One, we have the K shell, we have the L shell, we have the M shell, right? We have the N shell, and lastly the O shell. Is that right? So the principal quantum number N is the values that give us these shells. 1. So when you are counting it, the value for the K shell is 1, right? Now the value for the L shell is 2 in that order, 3, 4, and 5. Is that right? So the principal quantum number that gives us this value is the n. Is that right? It's the n that gives us this value. So when we see the principal quantum number for the value of the K shell is what? Is 1. So its n is equal to 1. Is that right? All right. So let's move on to the azimuthal quantum numbers. All right, so guys, we are going to talk about the azimuthal quantum numbers. Now, the azimuthal quantum numbers describes the shape of an orbital, right? I told you that the principal quantum numbers describe the size of an orbital. This must be noted. And the azimuthal quantum numbers describe the shape of an orbital, right? And what are the shape of the orbitals that we are talking about? 1, we have the s orbital, right? S orbital, we have the p orbital, the s orbital, we have the p orbital, we have the d orbital, the f orbital, the h orbital, and then the g orbital and the h orbital. Is that right? But in most cases, we only look up to the f orbital, because sometimes questions set based on the up to the f orbital, right? But as I'm explaining, you have to add the rest of the orbitals that you're having. Is that right? So the azimuthal quantum number describes the shape of the orbital, and then the letter that is denoted by the azimuthal quantum number is small l, right? So the value for the s orbital here is 0, right? It is counting serially. So 0, 1, 2, 3, 4, and 5. Is that right? So it is the L that gives us these values here. Is that clear? I told you that the principal quantum number describes the shell, right? But you have the K shell, L shell, M shell, and then the O shell. Is that right? And then the values, the principal quantum number that gives us those values is the N, right? All right. So I will tell you the names of these orbitals and also their shapes as well. So let's go. We have the S, P, D, F, G, and H, right? Now names and then the shapes. Now the name for the s orbital is spherical, right? Spherical. Now the name for the p orbital is principal, not principal. It's principal, right? It's principal, not principal. Now the name for the d orbital is diffuse. Diffuse. Diffuse here. All right, and the name for the f orbital is fundamental. Fundamental, right? And then the name for the g orbital is gravitational. Gravitational. And the name for the f orbital is each orbital is height. All right, now what are the shapes here? Now the s orbital, the name for the s orbital is spin, right? And then the shape is spherical. The shape is spherical. All right, then the principal, the shape is dumbbell, right? Then the d orbital, that's diffuse, the shape is double dumbbell. Double dumbbell. All right, then the fundamental is complex. Gravitational is complex. You see, so from the fundamental to height is complex. Is that right? So this is the orbitals, their names, and also their shapes as well. All right, so let's move on to all right, so guys, we are going to talk about the relationship between the L and then the N, right? I told you that the N is the principal quantum number, as well as the L is the azimuthal quantum number. Is that right? So we are going to talk about the relationship between the L and also the N, right? So This is the N. It describes the shell, and the L also describes the shape of the orbital. Is that right? So, but for solving this, we use a formula called the L is equal to